Welcome back. The objectives of this video are to complete more sample problems finding the complex zeros of polynomial functions. So here in example 5, we've got this function x cubed minus 3x squared plus x minus 3, and they ask us to factor this over the set of complex numbers and find all the zeros. So let's go ahead and factor this first. We have 4 terms, so we will have to factor this by grouping. And let's go ahead and we'll just set this equal to 0 because the zeros, we want our y value to be 0, and we'll solve and find those factors. So 0 equals x cubed. So we'll set it equal to 0. We get x cubed minus 3x squared plus x minus 3. We'll group in our pairs and we'll factor out our common factor of x squared. And we're left with x minus 3. And with the x minus 3, really the only thing we're going to factor out is 1. And we're left with x minus 3. So we get our factors of x minus 3 times x squared plus 1. We set each one of these factors equal to 0. And for the x minus 3, we're going to get x equals 3. And real quickly, x squared plus 1 equals 0. We do know how to factor that. We saw that in the last video, but we'll use the square root property. We get x squared equals negative 1. And we get, after we take the square root of both sides, we get x equals plus or minus I. Our factors then are x minus 3 times x plus I times x minus I. Example 6 tells us that the complex number z equals 2i is a zero of the polynomial. We want to find the remaining zeros of the function and factor it over the complex numbers. So our function 4x cubed plus 10x squared plus 16x plus 40 is a third degree polynomial. We do have 4 terms here. These are all even. We can take out a common factor. It looks like we can take out a common factor of 2. So let's go ahead and do that first. I can set the function equal to 0 now and set the 2 aside. I don't need the 2 that I factored out, so we get 0 equals 2x cubed plus 5x squared plus 8x plus 20. And we'll go ahead and factor that by grouping. I can take an x squared out of the first pair, and I get x squared times 2x plus 5. And I can factor out a 4 out of the second pair, and I get another 2x plus 5. It's all equal to 0. I'll continue to factor. So x squared plus 4 times 2x plus 5. Those are my 4 factors. And I solve. So I get x's of, well, this is going to be x squared equals negative 4. So we get x equals plus or minus 2i. We knew that already. We knew one of the factors was going to be 2i to begin with. And x equals negative 5 halves. And those are our 3 x-intercepts. Those are 3 zeros, 1 x-intercept. I'm not sure why I wrote that twice. And I've got our factors. Well, I do need to factor this still. We're really work backwards from our zeros. Factors of x minus a minus 2i and x minus a plus 2i. So that's going to be x plus 2i times x minus 2i. And the final factor is 2x plus 5. And now we have fully factored that. In example 7, they tell us x equals 1 is a zero of the function. And our function is 3x cubed minus x squared minus 7x plus 5. Again, a third degree polynomial, so we're going to have 3 x-intercepts. One of them is x equals 1. And we want to express those as a product of linear, irreducible quadratic factors with each with real coefficients. That is, factor over the real numbers. Well, let's go ahead and we can try and factor this by grouping, but that's not going to work. But they tell us that x equals 1 is a 0. So if x equals 1 is a 0, well, we know that x minus 1 is a factor. And since we can't factor this, we can do long division, or in our case, because we have x minus 1, if we divide by x minus 1, we could do this long division, then we could find out what the answer is. What I'm going to do is I'm going to use synthetic division, because if we're dividing by a first degree binomial with a coefficient of 1, we can do synthetic division. So if this is synthetic division eligible, we're dividing by our 0 of 1, so we put our divisor here, and in our top row we write all our coefficients. So our coefficients are 3, -1, -7, and 5. So those of you who haven't done synthetic division, I call that the coefficient row. And we're going to have 3 rows. We have a middle row, which I've just left blank. I call that the product row. And we'll get to that in a minute. And we're going to add down, so this is kind of a sum line here, and underneath we'll call this the sum row, which also has our answers. So we're dividing by 1 here, dividing by x minus 1. Our coefficients are here. We don't have any 0 or placeholders we have to worry about, because we have decreasing order of x, and we've got every degree is accounted for here. We're going to prime our pump, so we take the 3 or whatever the first coefficient is and we bring it down. So that's how we start. And then we multiply. We take our divisor here and we multiply by what we brought down by that coefficient. So 1 times 3 is 3. We multiplied, so we're going to put 3 in our product row. And then we add down. -1 plus 3 is 2. And we repeat the process. 1 times 2 is 2. Put that in our product row. Add down. 1 times -5 is -5. Put that in our product row and add down to our sum row. And now we actually have our answers. So 0 is the remainder. -5 is our constant. 2 is our x to the first, and 3 is our x to the second. So we've divided, and we've got 3x squared plus 2x minus 5. Now you may look at that and go, well, how does that help us, Mr. Cleary? We need factors, and we still have a trinomial here. Well, this we're going to try and factor. And since 3 is prime and 5 is prime, this should be pretty easy. Let's see if it's factorable. We can take 3x squared. We can only factor that to 3x and x. And our only options for 5 are 1 and 5. But if I put the 5 over here in the 4th position, when I FOIL back, 3 times 5 is 15. And I need to get 2 in the smile part. So I'm going to put the 5 here and the 1 there. And look at this. That's 5x. And 3x times 1 is 3x. And from 5x and 3x, I can get back to 2x. As long as I make the 5x positive and the 3x negative. And those are my factors. So my factors are x minus 1 times 3x plus 5 times another x minus 1, or if you will, x minus 1 squared times 3x plus 5. If I want to get greedy and get my zeros are x equals 1. That's got a multiplicity of 2. And x equals -5/3. So those are the 3 zeros or x-intercepts of that trinomial. And we'll get some more practice with this when I see you in class.